go to example 2.7.1 version B. So we've seen how to solve an equality. Now let's look at how to solve an inequality. Here I have x squared plus x minus 20 is greater than or equal to 0. So my first step is to solve it the same way we did as if it were equal. So this one is factorable. So let's factor. I need numbers that multiply to negative 20 and add to positive 1. So positive 5 and negative 4. Now, here's where I've got to be a little bit careful. Those are my two solutions, but my answer isn't just x is greater than or equal to negative 5, and then x is greater than or equal to 4. I've got to do a little bit more work than that. First, I'm going to make a number line of x values. And let's put those two numbers that we just got on that number line. We've got three intervals of numbers then. The numbers that are less than negative 5, numbers that are between negative 5 and positive 4, and then numbers that are greater than positive 4. So we're going to pick test numbers in each of those intervals. Now we can pick any number in that interval that we'd like. Ideally, we'd like to pick an easy number. So this first interval, I'm going to pick negative 6. I could pick negative 7, negative 8. I could pick negative 2,496,000, but that's way more effort than I want to do. So let's take that negative 6, plug it into my inequality, and let's see what we get. So I get 36 minus 6, which is 30, minus 20 is 10. Is that greater than or equal to 0? Yes, it is. So I'm going to put a yes there, and then I'm going to put a yes here. So I don't really care that the number is 10. All I really care about is that it's greater than 0, which is what we want here. Let's continue and do the same to my other intervals. I need an easy number between negative 5 and positive 4. 0 is probably the easiest, because here I get negative 20, and I think we can all agree that is definitely not greater than 0. Finally, I need a number greater than 4. Let's try 5. So once again, let's plug that in and see what we get. I get 30 minus 20, which is 10. And so yes, that is greater than or equal to 0. So it looks like I want those two outer intervals. Now, I can use my calculator to check. Now, you'll notice I'm graphing only the left-hand side. I'm only graphing the quadratic. I'm not actually graphing the inequality. And let's hit graph to see what it looks like. And I'm going to just repeat this here so I can make notations on it. So we can see, first of all, that we cross at negative 5 and positive 4. So we can use that graph to check our two solutions. Now, we want greater than 0. Here's 0, so where is it greater than? Well, it should be greater than above the x-axis. So the places it's above are over here on the left, and then over here on the right. And that's exactly what we got here. We got the left interval and the right interval. So my answer is negative infinity, comma negative 5. Remember that little u for or we use when we have two intervals. And then 4, comma, infinity. I've got brackets at the numbers because of the or equal to. Now, what I'm about to say does not work for every problem, but it will work for many of them, which is, if I have a quadratic greater than 0, then I expect, as an answer, the two outer intervals. Now again, that does not always work. It's not 100%, but much of the time that will prove to be true.